नमस्कार दोस्तों, मैं शिवानंद उपाध्याय आपका स्वागत करता हूं हमारे YouTube चैनल केमिस्ट्री एकेडमी फॉर आईटी जेई एंड नीट। This is our problem series for JEE Advanced. We are going to discuss the theory through problems. Hope this will be useful for all of you. I will request you to like and subscribe our channel. Question number 8. Which of the following plots represent non-acceptable wave function? तो पहले तो इसको underline कर लेते हैं they are not asking correct, they are asking incorrect statement. So what do you know about wave function, right? So whenever we are drawing psi versus r graph, because in all these things x is the distance, right? So they are discussing about psi versus r graph. What we know, suppose we are drawing for 3s orbital, so we know that the number of radial nodes is equal to n minus l minus 1, n minus l minus 1, so that is equal to 3 minus 0 minus 1, that is equal to 2. For s, it is maximum at the nucleus. So when we draw this graph, we are drawing graph like this. So this is psi versus r graph. Now what is the speciality of this graph? ये ग्राफ जो है वो कंटिन्यूअस है, कहीं भी ब्रेक नहीं है, राइट? हियर देयर इज अ ब्रेक. So if you compare, they are not matching because this is non-continuous, right? So we can say that the A option is non-continuous, while psi must be continuous. So this is non-continuous. Psi must be continuous. The second thing, in B option, if you see, and here if you see, if you take any value of r corresponding to one value of r, there is only one value of psi. So that is known as single valued function. If you see the B option, if I take any value of x, how many value of y I am getting? 1, 2, 3, and 4. So B option is not single valued. So B option is wrong. So psi versus r graph, it should be continuous, it should be single valued. Now, if we are moving to C option, you can find that there is a sharp point over here. And in terms of mathematics, we'll say that here we cannot differentiate the function, right? While we can differentiate the function of this everywhere, matlab if we draw the tangent and right, so differentiation is possible in this curve, while at this point differentiation is not possible, right? So the third condition is it should be, so here it is not differentiable at a particular point. At this point, we are saying that it is not differentiable. In D point, if you compare with this, all the things are matching. How it is matching? It is continuous. It is differentiable at each and every point. And it is single valued. If you take any point, we are going to get only one value, right? So D option is matching, right? So D is matching. D is correct, but they are not asking the correct, right? They are asking non-acceptable. So what is the answer? So answer will be ABC. So what are the points which we should remember for a wave function? It should be continuous, it should be single valued, and it should be differential at each and every point. Okay. Question number 9. A system is described by following real wave function. The probability P of finding the particle in a region dx around the point 1, 2, 3 in the figure obeys the trend. Okay. So when we are discussing, this is psi, it is not related to probability. When we are discussing about probability at a point, that is equal to psi square. And then we'll multiply. If we want to find the probability in a length element, then we'll multiply it by this dx. If we want to calculate in area element, we'll multiply by dA. If we want to calculate in volume element, we'll multiply it by dV. So the question is simple. We have to find that which point has maximum value of psi square. So you can see that this at the point second, at the second point, this height is maximum. So square of that will be highest value. Then third point, it is greater than the first point, the height over here, right? So we can say that the value of psi square maximum at the second point, then at the third point, and it is least at the first point. So the order of probability is shown by this. It is not shown by psi, cannot tell about the probability. Psi square will tell about the probability. So this should be the order. If we check, सेकंड पहले आना चाहिए, किस ऑप्शन में है, देन थर्ड आना चाहिए. सो बी आंसर विल बी करेक्ट. क्वेश्चन नंबर 10. An atomic state of hydrogen is represented by the following wave function. So wave function is given and it is a complete wave function because angular and radial both parts are there, where a naught is a constant. Which of the following graphs are correct? So whenever we are going to draw the graph, first before drawing the graph psi versus r, when we are discussing psi versus r, in our mind it should be like that it can have positive value, it can have negative value, it can have zero value. The number of radial nodes, we should know radial nodes is equal to n minus L minus 1. The second point, for s orbital, it is maximum at nucleus. For p and d orbital, it will be 0 at nucleus. So this is the behavior at the nucleus we should know. So knowing these points, we can draw the graph of psi versus r. Now, when we are drawing the graph of psi square versus r, what are the points which should we keep in mind? That it can never be negative, cannot be negative. Second point is that for s, it is maximum at nucleus, and for p and d, it should be 0. P and D should be 0 at nucleus. Important point is that the amplitude, as we move away from the nucleus, the amplitude should decrease for psi square versus r. Here, like amplitude is decreasing. The third graph is radial distribution function versus radial distance. It is always positive. It cannot be negative. It always starts from origin for SP and D. And as we move away from the nucleus, the amplitude of height should increase. So now we know all about the three type of graph. Now we go through the wave function and find out that which type of orbital it is. So r to the power 1, right? So from here we'll get that the value of L is equal to 1. Non-zero root. So if you put this is equal to 0, r is equal to 0 is not a non-zero root, right? So this is non-zero root. So we can say that radial nodes is equal to 1. N minus L minus 1 is equal to 1. The value of L is 1 here. So we'll say that N is equal to 3. So this is 3p suborbit. So this is suborbit radial wave function. Now we have to find angular wave function, only cos theta is there. So definitely it is 3pz. So now we have to relate that which graph psi versus r. So we can check here that for p at the nucleus, it will be 0. That is correct. Number of radial nodes will be equal to 1. So that is also correct. So the first graph seems to be correct. Pehla graph sahi hai. First graph is correct. Now B option, radial distribution function origin se shuru hota hai, ek radial node hai. That seems to be correct. This is also correct option. The third option, psi square versus r. For p, it is starting from 0 at origin, right? And the number of radial nodes is equal to 1. और जैसे जैसे हम जाएंगे, amplitude decrease करेगा. So this is also correct. The D option, if we are moving at nucleus, this is fine. But this is decreasing, right? This radial distribution function should increase with distance. So D option will be wrong. So the answer is equal to A, B, and C. A, B, C answer correct है.